right, we're going to pick up lesson 2 with writing equations of lines. We were just talking about slope and graphing. And so the next thing that we do is we have information about a line and we want to write its equation. So we do have that y equals mx plus b form. That's great. But there is another form that can be even more useful. And it's called the point slope form. So again, a non-vertical line because vertical lines don't have a slope. If you know its slope is m and that it passes through one point, notice this point is not necessarily the y-intercept, any point whatsoever, then here's how you can write the equation of the line. Y minus the y-coordinate of your point from over here equals slope times x minus, and then that's the x-coordinate of your point. Okay, so you'll find that this can be pretty helpful when you're going to write equations of lines, for example, through something like this first problem here, where I don't have the y-intercept. And so I'm going to have to either do some work to find it, which is less efficient. I can just go straight to my point slope form. Okay, so the steps to writing an equation of a line, you will always need the slope, no matter what. So if it's going to be given to you in some way, that's great. If not, you might have to use the slope formula. But you might also be given information about parallel or perpendicular lines. So keep in mind that parallel lines are lines that never intersect, right? They go up and up or down, could be down. And they're always going to stay exactly the same distance apart and not intersect. And in that situation, they have to have the same slope. The only way that they could not intersect is if they have the exact same steepness. So if you're given information about a line that's parallel to the line you're trying to write, then it will have the same slope as that parallel line. Perpendicular lines, on the other hand, those are lines that intersect at right angles. So a great example would be like the x and y axes. Those intersect at a right angle, a 90-degree angle. Okay. And their slopes are two things: opposite, so you have to change the sign, and reciprocals, which means you want to flip it, flip the fraction. Okay, so once you know the slope, then in steps 2 and 3, you're going to make your choice. If you know the y-intercept, if you were given that point, then you can just go straight to y equals mx plus b. But if you don't know the y-intercept, then I would go to the point slope form and just use any point that you have. So let's look at a couple of examples. For the first one, we're going to write the equation of the line passing through these 2 points. So I need the slope. I don't have the slope, so I'm going to use the slope formula. Change in y over change in x, which would be -8 over 6. Should I simplify? The answer is always. So now I have the slope, and I could use either one of these points. Remember, the point slope form from the previous page was this right here. So I could use either one of these 2 points that I was given and write y minus the y-coordinate equals slope times x minus the x-coordinate. And I could leave the equation there. There's no requirement that I have to solve it for y and put it in y equals mx plus b form. I know so many of us were trained like in Algebra 1. That's how we always had to do it. And so you just look, like if you're working on derivative, you just, or whatever homework you're working on, you just look to see, does it tell you to put it in a specific form? If it does, then you would solve for y. But in general, this would be perfectly acceptable if it just says an equation of the line. If you were to distribute, when I multiply 3 by -4/3, the 3's will cancel. And then I'm just going to add the 6 over, and I'd have y equals -4/3 x plus 2. So this is perfectly fine, but there's the mx plus b form. And our second equation, or second example, we want to find the equation of the line that passes through this point. I'm given this point. Notice it's not the y-intercept. because it's not 0 and then a number. And it's parallel to y equals 9x plus 3. So I don't know the slope, and where I'm going to find the slope information is this parallel to portion. So this is in y equals mx plus b form. So its slope is 9. And if I'm trying to write the equation of a line that's parallel to it, I would keep this slope because parallel lines have the same slope. So now I have y minus the y coordinate of the line that I'm looking for equals slope times x minus the x coordinate. And again, this would be perfectly reasonable, or I could solve it for y if the directions informed me that that's what I needed to do. Okay, we're also going to talk a little bit about modeling with linear functions, because one of the reasons we do functions at all is because we use them to describe relationships in the world. This is what we call modeling. So linear functions are used for situations or scenarios that have that constant rate of change. For example, if you are getting paid on an investment and interest at a constant rate, or a good or a service is charged at a constant rate. For example, your salary or your hourly wage, right? You get paid the same amount per hour. And so that is a constant rate. Or you get charged the same amount per item you buy. That's another constant rate, right? So that's where we would end up using linear equations. So, a couple of really quick examples here. Roger earned $78 for 6 hours of work and $169 for 13 hours of work. What is Roger's pay per hour? Multiple ways to go about doing this. A lot of people will just take 78 and divide it by 6 to get dollars per hour, and then just double check that by doing 169 divided by 13. That works. Or you could do the change in dollars over the change in hours, which will again give you that constant rate. So any way you do it, of those discussions, of those things that I just listed out, would work. I'm going to go ahead and look at the idea of doing it in a constant slope. I'm going to do 169 minus 78, which is 91, pulling out my trusty calculator over here. And then, of course, 13 minus 6 is 7, and 91 divided by 7 is 13. So $13 per hour. And if I did a quick check, 78 divided by 6 is 13, and I'm pretty sure 169 divided by 13 is also 13. So you could have gotten that answer a variety of different ways. One more quick example. Emily is a college student planning to spend the summer in Boston. She has saved $3,500 for the trip and anticipates spending $400 each week on rent, food, and activities. Write a linear model to represent the situation. So we need to kind of come up with an equation here. What would the independent variable stand for? I'm trying to turn that clacking noise that you hear off. And the dependent variable. So remember, the independent variable is the input, right? The x. And the dependent one is the y. So we're thinking of writing, something like y equals some function of x. Okay. So what would x stand for? What is the thing that's changing in this particular scenario? And a lot of times you can get that from the question. How many weeks will Emily be able to afford being in Boston? The thing that's changing, the thing that's constant is that she's going to spend $400 a week. Another constant thing here is that she has $3,500. What's changing is how many weeks will she be able to afford. So we're going to call x the number of weeks, right? And then basically her cost would be 400 times x. That is how much she is spending, right? And that would be what the y equals total cost, right, of being in Boston. So here is a linear equation that represents the situation. And then to answer the final question, how many weeks will she be able to afford? We'll set that equal to, well, if she has $3,500, that's what her total cost is going to max out at. So $3,500 equals 400x. And what would x be in that moment? So we would divide the 3,500 by the 400, and we'd get 8.75. So that's how many weeks she could spend. 8 and 3/4. Probably better to plan for 8. So she just has a little bit of extra buffer, right? In case she goes over that $400.